this entire research project that we're talking about now, it all came from an accident. I am Joost Kimpel. I work on the synthesis of conjugated polymers. This is a very fancy word for polymers that can conduct electricity. And in this group, we analyze the material properties of these materials as well. My father is a chemist, and ever since I was a kid, he would try to explain what chemistry actually is. And that didn't necessarily come from my direct interest, but it came from him being very passionate about his job. Then in middle school, I always asked for more chemistry homework because it didn't exist. And yeah, that's how I fell in love with the subject, let's say. And ever since then, it's been chemistry, everything. I did a master's degree at Oxford University, and here I worked on the synthesis of polyesters. Almost by chance, these materials, they conducted ions. So they conducted some form of electricity. It wasn't great, but they were used as materials in batteries to help with the ionic conduction and stop battery cracking. And I thought to myself, I had no idea that plastics, like polyesters, could conduct electricity. And through this, I got into the field of conjugated polymers. These electronic plastics, they're great. They have very amazing applications spanning from solar cells all the way to systems that we can use for biosensing, so for finding specific biomolecules. Unfortunately, conjugated copolymers or conjugated polymers, they're fairly tough to make. They have a very unsustainable synthesis. They have a lot of toxic components. They need high temperatures. They need inert atmosphere, so we can't just do them in air. We need to bring the reaction under specific systems. And this research specifically tackles that. So we managed to now do this reaction in air at room temperature and using much safer components overall, which then, if you use this for biosensing, is very important because we don't want things to be toxic anymore. Some of the ultimate goals in this research area is online diagnostics. So it would be where we use these plastics as, for instance, something that we could implant or we paste on our arm. And it could have certain readings of certain biomolecules or certain indicators of, for instance, high blood pressure, let's say. This is a very arbitrary example. And then rather than having to go to the doctor for, I don't feel so well, what is going on, you have a reading of your blood pressure or of your sugar values, for instance, if you have diabetes, and then you can act accordingly. I hope that this is a direction that we can go, but we are still in the children's shoes, let's say, of it. Especially with the implants, I think that there's a lot of ethical concerns there as well. But with a plaster on the arm and having an idea of some of these values, I think that is very, very valuable. From a, let's say, day-to-day basis, the most fun is when you get an idea kind of sporadically on the day and you think to yourself, I should just give this a try. Just see what it does. Because in the end, science is about exploration. With one of my coworkers, he had an idea of creating a certain setup. It was a Friday late afternoon. And well, what many people might be thinking is, let's go home and go to the pub or, relax. But he said, I'm very curious about this system. And I said, come on, let's go to the glass room and build it and see just what it does, if it works. And so we spent the Friday afternoon, build a very strange setup that ended up working. Being a researcher, you're confronted with a lot of failures as well. So these sporadic ideas or any research might be really fun, but unfortunately a lot of things also go wrong. Well, it always shows something, right? If something doesn't work, that is still a result that is challenging, but also very important to the journey of being a researcher. In the future, I'd wish for this to be implemented more in larger scale production of these conjugated polymers, because they have a wide range of applications, and now having a much greener or more sustainable method, I think it is a very important step in the right direction.